Hi, I'm Xiaohan from National Yangming Jiaotong University. I'm going to present our paper, VisGuide User-Oriented Recommendations for Data Event Extraction. What is data event extraction? When an analyst obtains a data table, she wants to know if there is any important or interesting information in this table. The analyst uses an exploration system to create some aggregate charts. Then, after multiple charts have been created, she may arrange them with logical connections. Chart sequence is the most common format for representing relationships between charts. Lastly, one or more chart sequences on the same topic can be gathered together and presented as a data event. However, there are three challenges in designing a system to extract data events. First, discovering informative charts. Second, organizing charts to depict a meaningful fact. Third, arranging facts to illustrate a data event. Therefore, here comes our two research core issues. 1. How can the system ensure smooth and continuous exploration? 2. How can the system satisfy its users' preferences? To tackle these two core issues, we propose VisGuide, which aims to support selection, organization, and presentation. For the selection, VisGuide provides next chart recommendations by taking some features into account, such as statistical properties, relations, and user preferences. For the organization, VisGuide is an interactive data exploration tool that users can interactively select charts through simple operations. For the presentation, VisGuide focuses on two common relations and adopts a tree-like presentation to visually present multiple charts. This paper makes the following contributions. First, VisGuide is an interactive environment from breadth and depth exploration. Second, user-oriented recommendation. And third, we design a study and metrics to evaluate user-oriented recommendation performance. Here is a demo of our system and the workflow. From the start, user selects a dataset and creates the first chart. Then user clicks a data point from the chart to request the recommendation candidates. The chart is called user focus chart, and the data point is used as a filtration condition. User can click Start button to express their interest. Click Add button to confirm their selection, and it will be added to tree view. The charts from drawdown will be placed at the right of the user focus chart, while the charts from comparison will be placed at the bottom. From tree view, user can click the Heart button to express their special like on such chart. Other detailed functions can be seen at our full demo video online. VisGuide contains two major modules, user interface and recommendation system. From the user interface, we collect user preference through their implicit labeling. The Start button indicates the user interest and the chart will get 0.3 points. Adding a chart to tree view will give the chart 0.6 points. Clicking the Heart button will increase the chart's preference score to 1 point. The goal of these labels is to collect the user's preference scores for training the recommendation model. A list of candidate charts is generated through the recommendation module, including two common patterns. One is drill down that analyzes by progressively adding filters. It means that charts have the same y-axis and be filtered from the clicked data point. The other is comparison that analyzes different x attributes from the common condition. To represent user preference of exploration, we define 5 features that consider both single chart and multiple charts. Properties from a single chart include point significance and deviation on data trends. For the multiple charts, the granularity and consistency of expansion style can also be seen as user preference. For details, please see our paper. The regression model will be trained online during the user interaction process. Each chart can be regarded as a sample that contains feature vectors. The rating labels will be the values of the equation. In addition, the model can be transferred to another dataset. The model weights can be reused except for the fifth feature. With the transfer model, VisGuide doesn't need to relearn users' preferences from scratch, and they will get a warm start on their next exploration. This is the last step of the recommendation module. The system acquires a user-focused chart and generates a list of candidates. Then the user preference model will predict the preference scores of all candidate charts. The candidate charts are sorted based on their predicted preference scores. The user exploration can continue on requesting recommendation and confirming selections. To evaluate our system, first we measured the usability of VisGuide by asking participants to fill out questionnaires. The results show that users are particularly satisfied with the flexibility and comprehensiveness. We also analyzed user logs and asked for their feedback. About 80% of the selected charts are from the top 3 recommendations, which means that they are satisfied with the recommendations. They also mentioned this guide supports systematic construction and useful guidance. In the second study, we compared this guide with a baseline, which doesn't support user-oriented recommendation. Each participant had 2 exploration sessions. At the first session, this guide trained the user model from scratch, transferring their model to the second session. We adopt 2 metrics to measure the performance of recommendation and the adaptation speed on changing preferences. NDCG is usually used to measure and evaluate the quality of ranking. Therefore, for the recommendation system, it can be used to evaluate the gap between the sorted list and the user's real interactions. We calculated that 0.7 corresponds to the case where 2 of top 3 ranking charts from recommendations are selected, thus assuming that the user is satisfied with such recommendation. We define 1 recommendation round as each time a user requests a recommendation. We also measured how quickly a recommendation engine can adapt to a changing preference, so we proposed a new metric called mean round to recovery. It calculates the average rounds to recover the recommendation performance up to the threshold of the certification score 0.7. A lower MRTR means that the model can adapt to a changing preferences in a short time. As the example shown below, there are 4 rounds where the NDCG scores are lower than 0.7, and the system takes on average 1.25 rounds to recover the user satisfaction. The results of 2 measurements show that this guide compared to baseline can adapt to user changing preferences in fewer rounds, and it also gives a better one-stop recommendations on new exploration. Here we discuss the benefits of this guide. First, this guide takes the advantage of semi-automatic creation to guide users to continuously explore data with simple operations. The tree layout also reminds users of their original intention. The other benefit is that this guide can consider both data properties and user preferences. The recommendation model can dynamically meet user satisfaction and provides a warm start when a user explores a new dataset. Then, what do we learn from implicit labels? Some participants pointed out that they couldn't judge the interestedness just based on a single chart, so the star on candidates is not useful. However, from our study, we observed that few user labels on 2 types are sufficient to train a model with high user satisfaction. This is surprising but important in some implication. When it comes to the inspiration for future works, more chart types and recommendation types can be supported. Using advanced learning models can catch more sophisticated user behavior. A comprehensive presentation such as annotation and infographics is still on the rise for data story creation. Above is all the content of my talk. You can scan the QR code for more details. Thank you for listening.